Hello, friends. Welcome to AI Ethics Part 3. I am so excited to be here. I really deeply, truly apologize. I am totally late. I mixed up my times, and we did the first two sessions at what is for me 7 p.m. And yeah, I absolutely blanked and assumed it was 7 p.m. today as well. But I am super psyched to have you here. Oh, look, we have some folks. Hey, welcome. Yes, I will throw on the crown. I very much owe you at least that for being late. I am also going to... Oh! There we go. Crown on. I am also going to take a peek at the schedule to see what is coming up, to see if we have things going on in 30 minutes. Because if we do, that's a bummer, and we'll try to work around that. If not, we can just go. We can stretch out a little bit. So let me just take a peek at that. Unless anybody already knows. Let's see. It's day 3. It is for me. Okay, yes. So we do have something starting in what is now like 25 minutes, which is actually okay, because we actually did not have that much more to get through in today's session and then Friday's session. Friday's session can be big and serious, and I will be on time, I promise. But what I want to do today is do a recap of what we talked about yesterday. Yes, Fancy, welcome. Yes, I did my whole mea culpa. I deeply apologize. I thought that it was the same time it was yesterday, and it was absolutely not. So I am deeply apologetic. Thank you for the check-in. And because we have ML algorithms coming up in 13 minutes, we're going to recap, and we're going to basically set the stage for our final day, which is really, we want to fix some of these things, right? So I think we're just going to jump back into the Colab that we used yesterday. So I will, let's see. Oh, nope, not that. That's not what we want. Okay, but here's the thing is, okay. Every time nope, that's wrong. There we go. OBS likes switching my monitors around. Oh, hello, GitHub Education. Good to see you. Okay, so we're back at our Colab, and I want to review what we did yesterday. So yesterday we kind of built our big serious model, right? Not that big, not that serious, but we used scikit-learn, and we used logistic regression, which I can scroll over to. We used our logistic regression class, and we added a couple of important sort of reality check things, right? We added our class weights, sort of forcing us to prioritize making sure that we don't give loans to people who won't pay them back, right? Because we're a bank and we want to make money, and if we're giving loans to people who won't pay them back, that's way worse to us than just not giving out an additional loan that will work out for us. Polar Void, hello. Did the stream get postponed? No, I'm just silly and bad at planning sometimes, unfortunately. Yeah, so I am absolutely late to the game. I'm looking at the schedule. I will possibly, if y'all are down, I will possibly jump back on stream I'll have to check with Mary and see if she's cool with, that's late. Maybe I'll just do it. But jump back on. It looks like we have something in like 20 minutes, but that shouldn't last. I mean, max it lasts 2 hours. So so maybe we'll jump back on the stream. But if I do, I'll post it in Discord as well, and we will get going. Cool. Yeah, Adam did ping me. Actually, partially Adam's ping is the reason that I jumped on when I did, because I was like getting prepared for the stream, and I was like, oh yeah, I got 30 minutes and then it's time to go live. And then I saw Adam's chat, and I was like, wait, this was 2 hours ago. Okay. I won't talk more about me being late, because that's not what you're here for. But we will review, and we'll try to set up the problem of, well, how are we going to try to make this more fair, right? And so we built our basic model, and we realized that by adding additional, here, I'll share this as well again. We realized that by adding additional forms of data, so by including our attributes like zip code and race, we were actually able to improve our accuracy. right? And we care about this because we want our model to be socially beneficial. We want it to basically give all the loans to people who will actually use them correctly. And we want to like really avoid, I mean, honestly, giving a loan to someone who is not going to pay it back, like in the country that I live in, we make that a terrible experience, right? Like getting foreclosed on is not a fun time. And so we want to get as good an accuracy as we can in order to avoid putting people in those positions where either they're not getting a loan that they really want to buy a house, or we're giving them a loan that's going to be irresponsible, right? And so after we did our economics of being a bank, we got down to what was our max profit model? Oh yeah, our max profit model got a 69% accuracy. Again, we were trading a little bit of accuracy for that max profit, right? We're sort of deciding to have fewer true positives in order to really minimize our false negatives, right? And then as we added additional data, the goal was to get above 69%, and we in fact did. We got 72% accuracy. But then the place that we kind of landed last time was, okay, well, how is this affecting folks from different racial backgrounds differently, right? And we saw it absolutely was affecting folks differently. There was, at least at the top level, we had this issue of, okay, there's differences in accuracy, right? We seem to be decently accurate on Asian folks and Black folks and white folks, but less accurate on Hispanic folks. But when we broke that number apart into not just accuracy, but looking at which kinds of mistakes we made, we saw even bigger differences, right? So this question of what kinds of mistakes are we making, this is what we call our confusion matrix. You'll also hear the term ROC curve, which is kind of a form of the same thing. We won't go too deep into that, but it's this idea of how often did we get it right when we gave people loans versus how often did we get it right when we didn't give people loans, right? So this first number, TPR, is basically what percentage of folks who should get loans got them. And this second thing, true negative rate, is what percentage of folks that shouldn't have gotten loans didn't get loans. And so you know that we are prioritizing true negative rate because we're the bank, and that's really, really bad for us when we have a false positive. But we are basically trading away a lot of that true positive rate, right? The true positive rate here is basically saying that if you would do well to get a loan, if that would work out well for you, you only have basically a 60% chance of getting it, right? And if we look at this by race, this is where things get sort of really, really distinct. So for Asian folks, 71%. So Asian folks actually have a better than average true positive rate. For Black folks, it is 27%. And so this was kind of the big place where we landed, where if you, conditional on being Black, if you apply for a loan and you would pay it back, you only have a 27% chance of getting that loan, right? Similar, the not quite as extreme for Hispanic folks. If you apply for a loan and you would pay it back, you only have a 46% chance of actually getting that loan. And then finally, for white folks, it's 64%, which is again like on the higher end there. And so I think the thing I want to do with the next 15 minutes is to try to motivate sort of why our model is making this mistake. And we will then, in our last session, actually improve our model. So let's see. Let me juggle some notes. Okay. So the thing I want to do is do a couple more visualizations that help us understand how we're making predictions. And specifically, the thing I want to look at is how good is our model at classifying folks who have high credit scores? How good is it at classifying folks that have low credit scores? And how good is it at classifying folks that have credit scores somewhere in the middle? And so the thing that I want to do, we can come down here. We'll say text. How good is our model at classifying folks with different credit scores? And so the visualization that we'll do, we can import matplotlib, splt, and actually let's reconnect and let's just run all. I usually try to avoid running all, but we're trying to move for speed today. We're trying to get her done. Okay, cool. So everything came back. So here's our question. We'll import matplotlib. And I guess the first thing that we can do is we can look at this for everyone, right? So what I want to do is I actually want to create a new value that is putting people's credit scores into groups. So the way that we can do this, so we have df credit score, right? And what we can do, if you want to put something in a group, there are sort of classier ways of doing this. But one thing that you can do is you can integer divide it by 50 and then multiply it by 50. And this will basically cut it off into groups of 50. And if we just run this and we just look at it, I guess we need some, parentheses. There we go. And we don't need this yet. Okay, so you can see the data that spits out, it basically chops you off at the sort of the lowest 50 mark that you're next to. And so we can call this df bin credit score. And what we're going to do with this data is we're basically going to see what percentage of folks at each bin are creditworthy and are not creditworthy, right? Or what percent of folks at each bin basically would default or would not default on a loan. And this will give us some sort of powerful insight into how our model performs at folks at different points in this credit score sort of range. So the thing I want to do is we can do df group by. We'll pass in our bin credit score. And we can say, the thing we want to pull out of this is creditworthy. And if we just run this, we can actually, not is credit worth, is creditworthy. We get a group by object, and we can aggregate that just by getting the mean. So what this does for us is it says, okay, folks with credit scores around 300, almost none of them are creditworthy, right? Folks with credit scores around 350, basically the same amount, almost none of them are creditworthy. At 400, 10% of them are creditworthy. And you go all the way up, and okay, if you have 850, like basically all the people with a credit score of 850 are creditworthy, right? If we have any questions about just the math we're doing here, is we're just seeing basically, or we're functionally making a histogram of like how many people at each spot did and ended up paying back their loans, right? And so what we can do is we can say data equals that. And we can actually just say data plot. Maybe before that we say PLT fig size. So I'm right here just saying, I don't know, let's say 6 by 3. Just want to make this graph a little bit bigger. And oh yeah, here we have to say import matplotlib. Okay, so we have a graph. We have a graph right here. So if you have a really, really high credit score, you are like, the way that I'd phrase this is if you have a really, really high credit score, you are easy to classify, right? If we just said, hey, if you have a high credit score, you get a loan, we'd get like most of them right? We would just say, oh yeah, like basically 99.9% of them will be creditworthy. So let's just give them all loans, right? On the other hand, if you have a really, really low credit score, so down here in the 300 range, you're also actually pretty easy to classify, right? That if you have a credit score of 320 or whatever, like we'll get basically 100% accuracy and at the same time, a 100% true negative rate by just saying none of you get loans, right? The place that our model has trouble is in this region in the middle, right? So like between, I don't know, maybe 450 and 650, if you're in between that range right here, you have somewhere between a 25% and an 80% chance of being creditworthy, right? And so there's just a lot of inherent uncertainty with this number if it's in the middle. And so this is a thing I want to put out there And I now want to view this through the lens of our protected class, which is race here, in order to get a little bit of a deeper understanding about what our model is doing in conjunction with our sort of max profit math, and how we're arriving at this situation where we have this this really, really big disparity in true positive rate. So the thing that we are going to do next, in fact, I'm actually going to make this a little bit wider. We can say, I don't know, 8. And I'm actually going to make it a little bit smaller. Let's say 2. Cool. And we can say PLT show to get rid of that. Have any questions about just what we have right here? I guess we can give ourselves a, what we can say, PLT Y label chance of what's the word? Being creditworthy. Wait, PLT Y label not. Oh, there's no underscore, is there? Cool. Our chance of being creditworthy and our bin credit score. And so now what I want to do is I want to do something we've done before with where we loop through all of our races and plot several graphs underneath this of the credit scores of the folks in our different racial categories. So we will say for race in sorted df race dot unique. So we're getting just the unique values in our race column and we're sorting them. And then what we can do here is we can actually just sort by race and basically grab a similar then we can just plot a histogram. So we'll say race df equals df where race is equal to race. Remember, this is kind of our syntax for filtering in pandas. And then we will do PLT histogram, and we'll just pass in race df credit score. So all this is going to do is just give us a distribution of, if you are in a racial category, how many of each of these credit scores do we expect to see? And then we'll say PLT show, and we'll hit return. Oh, and we're going to want to make that that formatting a little bit nicer. We can just get the same size there. Okay, cool. I'm going to zoom out a little bit. Also, okay, I'm getting rid of my y-axis just so things get aligned. Or I guess I can just add a y-axis down here to align things. You see this top graph gets pushed over by its little y label. We'll say y label, I don't know, frequency. And I guess we actually want to give them titles so we know what races we're looking at. We can say PLT title race. Okay, radical. So the thing that I want to look at is, do we have a shift in distribution where some folks, where some racial categories have more folks with credit scores in the middle where they're going to get misclassified? And just from looking at this very, very briefly, I think we can already kind of see the answer is yes. So for Asian folks, obviously, Asian folks, no matter what your race is, you can have any credit score you damn well please, right? Like that is a true statement. None of this is sort of deterministic, but way more Asian folks tend to have these credit scores that are easy to classify, being centered right around the 700 mark, a little bit below the 700 mark. Whereas, and I think it's actually pretty similar for white folks, it seems like maybe shifted down a little bit under 700. But then for Black folks and Hispanic folks are really, really peaking right in the middle. So basically, this means there are a lot of folks who are Hispanic, and if we scroll up, that have credit scores that place them right around being a coin flip, right? Similar with Black folks, there's certainly sort of like a bigger mass down at the bottom as well, but we have really the peak right here is right around 500, where that places you at like, yeah, you are about 40%. That's like pretty dang close to we have no information about what like the credit score says very, very little for us, right? So the way that I want to phrase this, and I know we only have like 5 minutes left, and I don't want the next stream to get pushed back. So I will pop out, and then probably we will hop back on later if anybody is down to stay up with me. But the way that I want to sort of try to put this into sort of plain English is that credit score as a variable is a way, way better predictor of white folks and Asian folks' credit worthiness than it is for Black folks and Hispanic folks in this data set, right? And this is what the bank is using. And so we can say that the actual metric that this bank is using is actually a biased metric that works better on some folks than on other folks. The way that this shows up in our actual algorithm is that because we have said, well, it's way worse for us to give someone a loan and have them not pay it back than for us to not give someone a loan. What this means is that when our predictor is bad on you, when it's basically a coin flip, we are always going to pick to not give you that loan because it would be more costly for us to make a mistake of having a false positive, right? This is, I think, kind of the crux. And I think if we can jump back into this for a few more minutes, I think this puts this in a good place to actually try to solve this on Friday. But sort of the whole thing here is that our predictor is actually a better predictor. It is a more accurate predictor and has a better true positive rate on Asian folks and white folks because more of them are in the regime where it gives us information. Fancy Appleby says, "Wait, Will, tell me what? The check-in doesn't work." This is possibly because the check-in because it is after the actual thing. So what I'll do is I'll drop my check-in form or my feedback form, and I will mea culpa to the powers that be and see if I can get registration reopened up so that y'all can actually get credit for being here. And that is actually on a great final note for me to just drop that feedback form. If you want to just put me on blast in the feedback form for being late, that's totally okay. I don't use this word often, but it's what I deserve. Okay, I'm going to drop that feedback form. Also, it looked like there were only 12 folks that submitted the last form. So that means if you submit this form, and you've submitted the other ones, you have a 1 in 4. You have a 25% chance of getting a swag drop. So pop in there, put me on blast for being late. Let me know how things are going if you have any questions. Also vote. Our final 2 things to vote on for me to do on stream are either for me to play Mary Had a Little Lamb on ukulele while standing on 1 foot and making animal noise for each chord change. And the other one is to act out a scene from The Silence of the Lambs. So hop in there and let me know what I should do. Thank you so much for being here and being flexible. I really, really appreciate it. And I will, if I'm able to, if all things go according to plan, hop back on in 2 hours and see you then. So happy Wednesday and happy hacking, y'all. Take care.